In this part of math, we are going to talk about a geometric sequence. We talked in the previous one about arithmetic sequence, and now we're going to talk about a geometric sequence. An arithmetic sequence, we said that it is 3, then if it is a sequence like the first term is 3, then we add, for example, 2, it's going to be 5, then you add 2, it's going to be 7, then you add. If we keep adding the same value as addition, this one is called what? Arithmetic sequence. Okay, what about geometric? Geometric, if we multiply by the same number, for example, 3, I multiply it here, then I get 6, then I get 12, then I get 24. So in each term, to find the next term, I multiply by the same number. Whatever is the number, it can be 2, 3, -1, negative, whatever is the number. Okay, so if it is multiplication, that means this is geometric. If it is addition, we add to get the next one. This is what? Arithmetic. So this one is arithmetic and this one is what? Geometric. Okay, in this part now, we are talking about what? Geometric and types of geometric sequences and how to find the nth term on the geometric sequence and how to find the sum of the terms. Good. If I have now, this is I start by, for example, 3, then 6, then 12, then 24. Okay, if I tell you now, this one is what type of sequence of is it? You're going to tell me it is geometric. Why? Because we are multiplying by a ratio to get the next term, number 1. Number 2 now, what is the 3 called? It is called the first term. The first term. Good. Now, if I divide 12 by 6 or I divide 24 divided by 12, what will I get? I'll get 2. What is the 2 called? It's called the ratio. So R, which is the ratio, is the number that we multiply these terms by it so that we get the next term. How can we find the ratio? Any number you divide it by the previous one. So 24 divided by 12 or 12 divided by 6 or 6 divided by 3, you get that the ratio is what? Is 2. Good. Now we find, if we find the nth term, this formula is important. The nth term, that means if I find the 5th term, the 6th term, the 10th term of any geometric sequence, which formula I use? To find the nth term, you find the first term, then you multiply it by the ratio power n minus 1. So the ratio is repeated as multiplication n minus 2 times what? The first term. Okay, if I ask now here, if I continue now, what will be the 5th term? So this is, as you see, this one is the first term, 2nd, 3rd, 4th. What will be the 5th term? We know we multiply just by 2, we'll get the 5th term, which is 48. Okay, can I use this formula now and I make sure that it will give me 48 as well? Okay, we're gonna do the 5th term, it equals the first term, and the first term here is given for me, that is 3 times the ratio. The ratio here is 2, as you see, power n minus 1. N is 5, is the number of terms that we want to find. So it's here 5. 5 minus 1 is 4. So now, as you see, 3 is there, and now 2 power 4. 2 power 4 is 16, and 16 times 3 is 48. So as you see, it gave me here, this formula, it gave me the 5th term, that is 48. Same thing here, when I multiply by 2, 24 times 2, I get also what? 48. So this formula now, I can find it to find the nth term, whether is it the 5th or the 6th or the 7th or the 8th term, whatever is the number of term, we can use it here to find the answer. So this is not the first formula, we use it to find the nth term. And this formula now, not just used to find the nth term, like how many variables are there? How many variables? You find here, this is 1 variable, this is 2, 3, 4. So that means I have 4 variables inside this formula. So that means when I'm given 3 of these variables, I'm ready mathematically to find the 4th variable. So sometimes they ask me about the ratio. I can use this formula. Sometimes they ask me about the first term. I can. Sometimes they find me the number of terms, which is n. I can, as long as they give me the other 3 terms. Good. Now, if we move to the next part, so the first part is to introduce what is geometric sequence and how to find the nth term of the geometric sequence. Second term is how to find the sum and what types of geometric sequence. Look here now. If I start by 8 here, if I start by 8, then the next term is 4, then the next term is 2, then the next term is 1, then 1 over 2, okay, then 1 over 4, and so on. This is now a sequence, and it is geometric. Good. Another type of sequence, like 2, I start by 1, and then 2, then 4, then 8, then I continue. As you see here now, this is the first term. Good. This is A1, and this is here A1. Good. What is the ratio on the first sequence? The ratio here is the next term divided on the previous one. So that means it's like 4 over 8, so it equals 1 over 2. Look, the ratio is 1 over 2. But here now the ratio is the first term here, and the ratio is 2 over 1, right? It equals what? 2. So pay attention. The ratio here is 1 over 2. That means less than 1. And the ratio here is 2. That means greater than 1. So when the ratio is less than 1, that means we go into smaller numbers. Look, we start by 8, then 4, then 2, then 1. So that means we get less value regardless of what the negative or the sign is. So that means we go small. But here now it is increases. So it starts by 1, then 2, then 4. So that means the numbers are increases. So those numbers that are increasing, we call them what? We call them divergent. This one we call it what? Divergent what? Sequence. While this one we call it what? Convergent. We call it what? Convergent what? Sequence. So you have now we understand what is convergent, what is divergent. Convergent, by the way, convergent when the numbers when we go with numbers and the numbers they become close to each other. So 8, then 4, then 2, then 1, then half. As long as you go next terms, you see that they become close to each other. Like 2, look, the difference between 4 and 2, then the difference between 2 and 1, it becomes the difference now between 4 and 2 and 1 becomes closer than the difference between what? 2 and 4. So the differences becomes smaller. So numbers are then the next terms becomes closer to each other. In this case, we call it convergent. But here, as you see, the numbers becomes further from each other. So 4, then 8, then 16, then 32. So they become far away from each other. So we call it what? Divergent sequence. Good. Now, this is how we classify them, convergent and what? And divergent. We have another classification, which is finite and infinite. Look, this one now, which is convergent, I'm talking about this one here. I'm talking about this sequence. This sequence now, if I don't give you its end, where do you think will be its end? Look, if I continue 8, then 4, then 2, then 1, then 1 over 2, then 1 over 4, then 1 over 8, then 1 over 16. Look, you go and your ultimate result will be close to 0, will be ultimate what? To 0. So in this case now, you're going to get the idea that in the end, the final numbers will become what? Close to 0. So you know its end. So in this case, I will not tell you what's its end in this case. And in this case, also where the end, you know what? It is called infinite what? Infinite sequence. Infinite sequence. And for this infinite sequence, to find its sum, to find the sum of the terms, just you find the first number, the first term, over 1 minus the ratio. Over 1 minus the ratio. So in this question, what is the sum? 8, 4, 2, 1, 1 over 2. What is their sum? Their sum will be the first term, which is 8, over 1 minus the ratio. What is the ratio here? It's half, so minus half. So 1 minus half is half. 8 over half is going to be 16, as you see. So the sum of these ones, 8 plus 4 plus 2 plus 1 plus half plus 1 over 4. If you add all these numbers till the infinity, in the end, their sum will be what? 16. So this one is called convergent, and it is called infinite, and its sum is this one. Okay, now we go to the next type here. We are talking about here divergent. Okay, divergent in this case, by the way, usually we give you the last term. Why? Because, or number of terms. Because now you can't estimate what will be its end. Its end will be about infinity, right? So that means it's going to be what? Going to infinity. So if it's going to infinity, it's hard then to find its sum. So in this case, to find its sum, I need to give you its final number or its end. So to find its sum then, it's going to be A1 over 1 minus R over 1 minus R. This is now similar to what? Similar to the previous one, but 1 over R, then here you multiply it also by 1 minus R power n. 1 minus R power what? Power n. This is now for this sequence, and this sequence we call it finite. Why we call it finite here? Okay, because I'll give you its end. I'll give you, for example, now you stop at the 15th term or the 51st term or the 15th term. That means you stop here. So if you stop here, that means I give you its end. So you call it finite. So finite, that means the end number of terms or the last term is given for me. So I know its limits. I know where it starts, where it ends. So we call it what? Finite. And this one, finite here, we find its sum this way. But what about if the last number is not given? So the sum will not be easy then to find it. So if it is infinite and divergent, in this case, you will not be able to find the sum, and the questions will not come to you. So that means the questions may come with that are related to find the sum. You find the sum if it is convergent and it is infinite, like the previous one where it is decreasing in its results. Then this is the formula to find the sum, and here to find the sum if it is going higher, that means divergent. And we're going to apply these ideas on the coming questions. So we have 3 formulas that you need to remember on the geometric sequence. One to find the nth term, one to find the sum for the infinite sequence, where the ratio is less. Here, the ratio, which is R, is what? Is less than. So the ratio of R is less than 1, right? So that means it's like 1 over 2, 1 over 3. So the ratio is less than 1 here. You find this formula. If the ratio is equal to 1 or greater than 1, in this case, you find what? You find this formula, because it's going to be divergent sequence. So I hope it's clear for all these notes. That's it. Thank you. See you in other videos.